All right, so we are live, everyone. My name is Jesse, and I'm with Exploring by the Seat of Your Pants. For those joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world. And of course, there are no classrooms right now. All of you guys are stuck at home watching it on YouTube, so we appreciate as you continue to tune in as we highlight amazing scientists, explorers, and facilities from around the globe. Today, I am super excited. We're bringing her back for the first time during this time where everyone's at home, but we've had her on the program many times. We are joined live in Pasadena, California by Dr. Abigail Fraeman. She is a NASA research scientist at the storied Jet Propulsion Laboratory in California, one of the most elite research facilities in the world. And specifically, she focuses on Mars as the deputy project scientist for a variety of amazing missions that have gone up to the red planet. And because of this cool job, she gets to be the first person to see images brought back to us from another world. Surely one of the coolest gigs you can possibly have. And so without further ado, and with Mars as her virtual background for the time being, I'm going to turn it over to Dr. Fraeman. And thank you so much for joining us. And take it away.
Fantastic. Thank you so much for inviting me. I'm so excited to be able to talk to everybody today about my job working on Mars, what it's like, how I got here, what I do every day. And so why don't we just go ahead and jump in, and I have some images to show everybody, and then I'm happy to take any questions. So we'll go down here to share screen. I'll share my presentation here and pop that open. Looks good? Great.
Yep.
All right. Oh, wonderful. Thank you again so much for having me. As mentioned, I work at a place called the Jet Propulsion Laboratory, and my job is a scientist. And what I really get to do is explore Mars. So here's a picture when I am at work of where I get to work, which is one of several NASA facilities called the Jet Propulsion Laboratory. We are located in Pasadena, California, which is a city right outside of Los Angeles. And it's this really wonderful place. It's very much like a college campus. We have a lot of different buildings. That arrow is pointing to my building and specifically, but we have about 5,000 scientists and engineers and business people and science communicators and all kinds of people who work here at the Jet Propulsion Lab, or as we like to call it, JPL. Everyone at NASA loves acronyms. Now, it might be a little confusing when I say I work at NASA, I work at JPL. What's the difference? What does that mean? Well, now a collection of many different research centers all around the United States. So JPL, Jet Propulsion Lab, is circled here in red over in California on the west coast of the United States. But there are facilities all over the country. Each facility specializes in something a little bit different. At JPL, we specialize in robotic exploration of the solar system. So sending rovers and orbiters and spacecraft out to explore the planets. Some other facilities you might be really familiar with, Johnson Space Center in Houston. They're in charge of all of the human space flights, so the astronauts. So if you remember the famous line, Houston, we have a problem. Those are astronauts talking to people at Johnson Space Center. There's Kennedy Space Center down in Florida. That's where all of the launches, or a lot of the launches, happen down in the East Coast in Florida. And then, of course, NASA headquarters is a building in Washington, D.C. So we're all over the country doing all sorts of different things. But again, at JPL, where I work, we specialize in robotic exploration of the solar system. Now, many planets in the solar system, so much to explore, but my favorite planet, the place that I explore the most, is this area right here, Mars. Mars is the fourth planet from the sun. It's right next door to Earth, and it's a fascinating place to study for several reasons. First of all, there's this big question about whether or not there was ever life on Mars. So we know today Mars is very, very cold. It has a very thin atmosphere. There's a lot of radiation that reaches the surface. It would be a really lousy place to try to live, for life to be right now. But we think that probably 3.5 billion years ago, Mars was a lot warmer and its climate was a lot more like Earth's at that time. And so we begin to wonder, since we think life arose on Earth around then, could the same conditions have existed on Mars, and could life have arisen on Mars then too? We don't know the answer to that question. And that's one of the biggest reasons we like to explore Mars, to search for any evidence of whether or not life arose independently on this other planet in the solar system. And think about, if we find the answer is yes, I think that's one of the most profound things that we could possibly learn. Because if we learn that, it means that there's life on at least 2 planets in our own solar system. And then think about the thousands and thousands and thousands of planets we're finding around other stars and other solar system. And that would tell you that life is probably really common throughout the universe. Wouldn't that be amazing to find out? I think so. Mars is really interesting in and of itself as a planet because it's also a wonderful laboratory to help us understand how planets themselves work. As I mentioned, Mars a long time ago was really similar to Earth in terms of its climate, but today it's very different. So there's a big question about what caused that huge change. Why did Mars become cold and dry and lifeless, and Earth became this warm, wonderful place to live? What are the factors that drove that change? And then what can we learn about that in terms of thinking about these planets elsewhere in our solar system? What is it that makes a planet habitable or not habitable? These are all questions that we can answer by studying Mars and comparing it to what we learned from Earth. And then, of course, there's always the wonderful, exciting prospect about going to Mars. It's so close. It's such a place that we can explore. And this is something that we really want to do. We want humans to go to Mars. Maybe one of you guys will get to go. Wouldn't that be awesome? But before we send humans, we need to understand, what are the environments going to be like? What are the challenges they're going to face? And what are some resources we might be able to use from the surface of Mars itself? So these are all really important questions, and the big reasons that I think studying Mars is so much fun and so interesting. How do I do that? Well, I study Mars by studying its geology. That is, I look at the rocks and I look at clues that are preserved in the rocks of Mars to figure out what it was like billions of years ago. It's kind of like a detective at the scene of the crime. To learn how to do geology on Mars, one of the great things I get to do is geology on Earth. So here's some pictures of me at some really fun field sites here on Earth that are reminiscent of Mars. We get to go to the desert where it's really, really dry. Places like Iceland, where the composition of the rocks are really similar to the composition of the rocks on Mars. And, also Iceland's pretty cold and icy, just like Mars. All sorts of neat areas. I also studied geology on Mars directly by looking at data from satellites that are orbiting the planet. Here's a picture of some of the satellites we have orbiting Mars. There's actually many, many more, and they're sending back all different kinds of data about pictures of the planet, what it's made of, what its weather is, where ice is, all kinds of amazing information. Here's an image showing some of the pictures that we're getting back from the surface of Mars. This is from a camera that's called HiRISE. This image has a resolution of 25 centimeters per pixel. So, you could resolve something maybe about 50 centimeters big on the surface from orbit, which is really cool. We see these beautiful layers that are eroding. There's kind of boulders coming off of these layered outcrops. Here's another picture where we see just fields and fields of dark basaltic sand ripples blowing across the planet. Here's another site that's really exciting. That's called Jezero Crater. This site is really cool because kind of cutting through, this is the rim of an impact crater. And leading into this crater, we have this big channel that ends in this kind of funny looking shape, which is actually a delta. So we think that this crater was once filled with a lake that had rivers coming into it that kind of had the material they were carrying settle out very gently, very slowly, form this feature. And then the colors you're seeing, these are not the colors of Mars. These are actually colors that represent the minerals that are on the surface. And what we can see is that these minerals that are present are the kind of minerals that form in water that's very drinkable, that form in water where life would like to have been present. And in fact, this site is so interesting and so exciting that NASA is going to be sending our next rover here. That rover is called the Perseverance rover. It's going to be launching in a few months, and I'll talk a little bit more about that at the end of the presentation. But how did I get interested in exploring Mars in the first place? Well, I attribute it a lot to this rover. There were actually two that were identical, named Spirit and Opportunity, that landed on Mars in 2004. And actually, this picture behind me, this is a picture from Opportunity. Before Spirit and Opportunity landed on Mars, this is what our view of the surface looked like. It was this, or before Opportunity landed, I should say. This is what Mars looked like. It was this very rocky, kind of light red planet, big, boulders kind of everywhere. These are all basaltic rocks. These came from a volcano. They were broken up. And this is what I thought Mars looked like. But all of that changed when Opportunity landed. And this is what Opportunity saw. This was the first image, or one of the first images, that Opportunity sent back. And it's so different. It's these just really dark sands. And way in the background, you can see this tan kind of rock sticking out. This is actually bedrock. And to geologists, this is geologic gold. This is rock that tells you something really important, because it's rock that's formed in the place where you found it. It's very different from the volcanic chunky boulders we'd been seeing. And in fact, here's a picture of me seeing an image like this for the first time. I actually had an amazing opportunity to go to the Jet Propulsion Laboratory as a high school student. I was 16 years old in this picture, and see this image come down for the first time. And it blew my mind. You can see my face right there. I'm just completely like, what is happening? And it was so cool because I was in the room with a bunch of scientists. So when they saw this, they were as excited as I were, but they knew how significant it was. They knew is that bedrock in the background they were saying, or is that cross bedding I see in the bedrock? What's going on? And I didn't know what any of that meant at the time, but I realized that I wanted to know, and I wanted to be one of these people who could see an image like this and understand why it was so exciting and so significant. And so I think this is actually a picture of the moment where I decided that I wanted to spend a career studying Mars, which is a very special moment for me. And this is what it looked like. So this is my career path, and it's actually plotted with Opportunity's traverse across Mars. Opportunity was supposed to last for 3 months. It did a little bit better than that, going for about 14 years. And in that time, I watched it land in this site called Eagle Crater. I graduated from high school. I started college. I did a summer research internship where I worked on data from the rover. I graduated college. I started graduate school. As a graduate student, I became involved with the rover's tactical team. I picked up a master's degree. I picked up my PhD. I started something called a postdoc at the California Institute of Technology. And then I got hired at JPL as a research scientist. The rover was still going. And at that point, I came onto the project. I was appointed a role called the Deputy Project Scientist, which I served in until the end of the mission about a year ago, when a big dust storm came and ended the mission. So it is an extraordinary mission, and you can, I think, extraordinary to see my career path plotted along everywhere that Opportunity explored. But today, most of my day is spent working on this guy. This is the Curiosity Mars rover that landed on Mars in 2012. For comparison, here's an image of the first rover, this tiny guy right here. This was the Pathfinder rover that landed in the 90s, first rover we ever sent to Mars. This is the size of Spirit and Opportunity, and Curiosity is this guy way over. It's huge. It's a huge rover about the size of a Mini Cooper car. It has a much more advanced suite of scientific instruments. We're making the rovers bigger, more capable. This is where Curiosity landed. It's a site, another impact crater called Gale Crater. And this crater was particularly exciting because there's a mountain in the middle of it. The mountain's about 3 miles or 5 kilometers tall. And from orbit, we can see that the mountain is made of these rock layers. And so what we wanted to do was land at the base of this mountain and then climb up and read the layers like you're reading a history book of Martian time. This is what it looked like when we first landed. Here's our view. We couldn't land on the mountain. It wasn't safe. The terrain was too steep. So we landed on the floor next to it, and you can see it in the distance. The mountain is named Mount Sharp. But even on the floor of this crater, there was really interesting findings. Here's a picture of some of the rocks we saw almost right away. And you can see it kind of looks like a piece of concrete with these rounded pebbles in there that are about a centimeter in size. What we could tell is these are very similar to the sorts of rocks that form by rivers on Earth, when you have rivers carrying big pebbles and rounding them as they go. Here's a picture of the Mars rock compared to a river Earth rock, pretty similar. This is a view that we saw of the mountain looking off into the distance. You can see all of these layers and layers and layers that we'd seen from orbit, and we're very excited to be able to explore as we got closer. And as we got closer, we saw even more layers, and we saw very, very fine-grained parallel layers. And this is the kind of rock that we know forms in lakes on Earth. You need a very calm setting to make a rock that looks like this. And so putting this all together, we realized that this crater was once the host of an ancient lake where we had rivers coming into the crater and filling it up and forming this lake. And even more exciting, we've been studying the composition of the materials the lake left behind, and we found things that show us that the waters were probably very drinkable. The water was probably around for millions, if not tens of millions of years. And there were organic molecules. These are molecules that contain carbon, that are the building blocks of life, floating around in this lake. So combining all of these observations, we think this would have been a great place if Mars had ever had life. It would have been a great place for life to have existed. So we found what we're calling a potentially habitable environment on Mars. Whether or not there was life here, well, that's another question that we still need to answer. What's a typical day of planning a rover like? Just for fun, this is kind of what a timeline is like every day that we're driving Curiosity. From about 8 to 8:15 in the morning, we all kind of get together, look at what the rover did the previous day, think about, what we want to do the next day, make sure there are no problems. From 8:15 to 9:45, we have a big team that starts to work. The science team works on one side where we're thinking about what observations we want to make given what we saw. The engineering team is also working hard to start putting the basics of a plan together, including focusing on non-science activities. From about 9:45 to 10:15, when everybody's sort of finalized what they think they want, we start to integrate everything together to make sure it fits. From 10:15 to 11:30, we go over the plan in detail with everybody in the same room together, making sure that we're not broken in terms of things like the time we want to take, the power we want to use, the data volume we want to collect. From 10:45 to 2 p.m., the science team then goes off on our own again, and we start talking about our recent findings, what we're discovering, what we think it means. And then we also think about what do we think we want to do tomorrow based on what we think we might find today. In concurrence with that, the engineering team goes off on their side and they start really refining the plan. They start writing the actual lines of code that will be sent to the rover. And they also have meetings where they review every single line of code line by line out loud, so everybody can double check that there's no mistakes. And then later that evening, we send the plan to Mars, and then we get ready to do it all over again the next day. This was our view a few weeks ago. We were finishing up drilling a piece of the Martian rock to analyze a campaign, and we decided we really wanted to drive up this hill to this flat capping rock on top. This is called the Greenhue Pediment. We weren't sure if we would make it because we had to drive up slopes that were 30 degrees, like really, really steep slopes. The rover had never driven up slopes that steep to climb this hill to get to the top. But we did it. And this is our current view right now. This is the view from the top of that pediment. It's just been spectacular. We just finished up drilling a rock, and this morning we're making our plan to start driving away. But it's been a really fun couple of weeks for the rover, exploring new areas and exploring new kinds of rocks. I'll go ahead and I'll wrap up just showing a teaser, as I mentioned, that we're actually sending another rover to Mars in just a couple of months. This rover was just announced. It's named Perseverance, the Perseverance rover. Here's a picture that I took of workers working on this rover at JPL just a few weeks ago, right before it was all packed up and shipped to Florida, where they're making just some final tweaks before it gets ready to be put on the rocket, where it will launch to Mars in July. You can see that this rover looks pretty similar to Curiosity. There's one really, really big difference in that instead of a drill to sample the rock, it has a sample coring where it's going to go and collect the chalk-sized cores of Martian rocks, seal them up in these tubes, and then kind of drop them along the road. And then there'll be a follow-up mission where we're going to go and actually pick up these specially collected tubes and bring them back to Earth so we can study Martian rocks in the laboratory. And we think that's going to be a really important step to help us answer the question, not only did Mars have environments that could have had life, but did Mars have life? So really excited for this mission. I think it's going to teach us so much more about Mars, and launching in just a few months. I'll end with this slide with some information about Curiosity. You guys can explore along with Curiosity real time, just like me. We have a blog that we update every time we put a plan together that you can follow. You can just Google Curiosity Mission Update blog or go to this link. And then all of our data are posted real time on the internet. So you can look at images that come down the same time I do. These are available for anybody anywhere in the world to see. So if you're interested, I encourage you to follow along, check out these sites. And with that, I'm happy to take any questions.
Fantastic. Well, thank you so much for joining us again, Dr. Fraeman. And again, looks like you've made it to Mars. I'm very excited for you. That's fantastic behind you there. That's awesome.
Plans of Meridiani Planum.
Yeah. For everyone tuning in on YouTube, welcome in. Just let me know where you're joining from. I know we got a whole bunch of kids from Brampton, so welcome in for you guys in Ontario. And please type in as many questions as you'd like. I'm going to start us off with one we get every single time, and that is, do you have a favorite part of your job?
Yeah, what's the favorite part of my job? It's so much fun. I think two of my favorite things are getting to come in every morning and see something new, see something that no human has ever seen before, and think about what does that mean. I really feel like an explorer, which is so cool. I think the second thing I really love about my job is the people I get to work with. Driving a rover on Mars cannot be done by one person by themselves. It takes a team of hundreds, if not thousands of people. And to be able to work on a team of people who are all so smart and so passionate and so excited about what we're doing is such a blessing. And I love the team aspect of this project.
Amazing. I'm not sure anyone's quite as excited as you on your team, but that's it's good to have some equally enthused colleagues. All right, Hannah wanted to know, what type of schooling did you need to have to get a career like yours? What's your, what would you recommend to people that wanted to end up in a job like a NASA research scientist?
Yeah, that's a great question, Hannah. And I can tell you what I did, and then I can tell you what I think you should do. So for me, I studied a lot of math and computer science and science, of course. My undergraduate degree, I double majored in geology, which was really fun, and physics, which has been really helpful. And then I got my PhD in something called planetary science, which is basically geology on other planets. That all said, I think you should do, if you're interested in being a NASA research scientist or just working at NASA in general, is find what you like to do and follow that. So there's all kinds of people who work at NASA. There are scientists and geologists like me. There are biologists, there are chemists, there are physicists. There's basically studying the other planets requires all the different scientific disciplines, but it goes beyond that. So if you're not that into science, well, of course, there's all kinds of engineering, aerospace, mechanical, every flavor, electrical you can think of. All of those different kinds of engineers are needed to build spacecraft. But it goes even further than that, because as I mentioned earlier, it's not just scientists and engineers who work at NASA. We need all kinds of people. We have lawyers who work for us, who help us figure out the legalities of what we're doing. Space law is a thing. We have a lot of business administrators who help us manage our funds and make sure everything runs smoothly. We have artists and educators and communicators who work to convey to the public the work that we're doing. And I think that's particularly important, because what's the point of doing all the science and exploration if you can't tell anybody about what you're finding? So the one thing that I think everyone who works at NASA in common has is that they found what they loved to do, and they found what they were passionate about, and then they figured out how to apply that to this problem, or this joy of exploring the solar system. So, if you're interested in a career at NASA, you can take the path I took, but also think about what is it that you like, what are you good at, and I bet there's a way to find out how that would fit as well.
Fantastic. I like that you highlighted art things in there too. I have a book in my own library. It's just like travel posters for other planets in the solar system. And I forget who did it. Might have been Jim Bell, but there's so many opportunities out there and we highlight that every time. I've also forgot to mention today into tomorrow is like a huge NASA day. We've got Mark Raymond, we've got Farah Alibay, we've got Babak Ferdozi tomorrow, and an astronomer later today. So Abigail, you're kicking us off on an epic day of space exploration. So I want to highlight that to people at home. All right, a technical question for you from Lizzie in Toronto. Is the ground of Mars, is the sort of the substrate, the same temperature or different temperature as the atmosphere above? Do we have data on that?
Oh, that's a wonderful question. Yes, we do have data on that. Curiosity actually has a weather station that measures the temperature every hour, and it has two temperature sensors. One is for the air and one is for the ground. And it's precisely because they're not the same temperature. And so we like to see how both of them change throughout the day. So that's a really good question. No, they're not the same temperature.
And is it, I mean, Earth is obviously very varied. We have a huge variety of habitats, but the atmospheric temperature as opposed to the ground temperature must be related in some way. I don't know if you have any knowledge on how that relates to how it is on Mars, or we might be diving too deep in here, but I'm just curious if there's anything else you can share about that.
Yeah, well, one of the interesting things we can find by studying the ground temperature is how fast the ground heats up and cools down is related to its properties. So if you have a ground that's very sandy, lots of very fine grained sands, it'll heat up very quickly and it'll cool off very quickly. If you have ground that's composed of a lot of bedrock, it's going to take a lot more to heat it up and a lot more to cool it down. So we can measure how quickly the temperature of the ground changes, and that tells us something about what it's made of. And so we look at this from the rover. We also have orbiters that are designed to measure how the ground temperature changes, and that tells us something about its physical properties.
Very cool. So you shared this poignant experience that got you fascinated with Mars, and obviously it's been such a huge pleasure for you over the course of your career. Is there a place that, other than Mars, you would most want to explore in the solar system personally?
Oh, I would love to go to Venus. I think Venus is so cool, and we know so little about it, and it's so important in this puzzle that I talked about, how planets become places for life or not. Venus is basically Earth's twin. It's about the same size as Earth, but it's such a different place. It's become this kind of very, very, very hot, very crazy surface environment. So why did Venus become such a hot planet that's inhospitable for life, and Earth became the place it is? And then Mars became cold and dry. We need to visit all of these places to answer these questions. And so, yeah, I'd love to explore Venus more. I think it's such a great place.
Awesome. Very cool. We don't usually get Venus as the alternate for people that are keen on Mars. So I like that was a question. All right. KS from Brampton wants to know, did you want to be anything other than a NASA scientist, or was that your dream job? Was there anything else that was pulling your attention in any other direction?
Yeah. Well, I've always really liked science. Growing up, it was something I enjoyed. Not all of my colleagues have that same story, but for me, first I wanted to be a chemist, and then a high school chemistry teacher, and then I wanted to be an astronomer. I wanted to be an astronaut for a while. But ever since college, I've kind of settled on NASA research scientists studying other planets. But I also always had the perspective that if something that I thought was cooler and more fun came along to me, then, I had no problem switching. I just never found anything that I was more excited about.
We can tell. That's awesome. All right, we're going to take a couple more questions before we wrap up. Amazingly, we're already at the 30-minute mark. So Abigail, the question we always get, I'm surprised no one's actually typed it in, but it's been in all of your live sessions with lots of classes. Alien life in the universe. I mean, we're looking for traces of life on Mars. What do you think about the prospects of life or intelligent life or both that you can share with us?
I think the prospects are very high. I think there are too many planets in our universe for life to have only occurred on Earth. I think the probability of that is just so crazy. There must be another planet where whatever formed life on Earth happened on that planet as well. Will we ever find that planet? I don't know. I hope so. I think it would be amazing if we did. But I think the odds are they're in our favor that there is life somewhere else in the universe. We just have to find it.
Super cool. All right. And then before we wrap up, for kids tuning in at home, they've learned about your story. They're super excited. They want to find out more about Mars. You passed along a bunch of resources in your last slide. Where else can we send kids to learn? Whether that's a series online, books, any resources that really inspire you that we can share with kids.
Sure. Two come to mind immediately. First, a couple. So there's NASA. NASA has a ton of resources. You can go to their website, and I'm sure you can look for links about education. They have something called Eyes on the Solar System, which are some great images that you can use to explore the solar system. I know JPL, through their education office, has also put out a lot of material that you can look at, especially while you're learning from home. So check out the JPL website as well, and look for the educational opportunities. And then there's also an organization that's very near and dear to my heart called the Planetary Society, which is an independent space advocacy organization that is international. They have members from all over the world. And part of their mission is also to educate. So if you go to the website of the Planetary Society, you'll find lots of resources, up-to-date information about all of the missions from countries across the world to the solar system. And then I'll also put a plug. The program I did that got me involved in space exploration was run by the Planetary Society. So I think they're a great resource for connecting people to learn about this field.
Fantastic. Pretty much every time we do a space session, we end up highlighting the Planetary Society. They really do have a bevy of fantastic resources. I also want to encourage kids at home to watch the Cosmos series, which has been recently released. So if you have Disney Plus, you can check that out. The old Cosmos series, the middle one, the new one, all really, really cool resources featuring some fantastic space imagery and ideas. Dr. Fraeman, thank you so much for joining us once again. We so appreciate you being here today. And
Thank you so much for having me.
You're welcome. For everyone tuning in at home on YouTube, thanks so much for watching in. Check out the rest of the day. Some amazing NASA research scientists coming up. And for now, talk to you all soon. Have a wonderful rest of your day.